Disseminated types of mineralization are formed by the crystallization of deep-seated magma. The early formed in situ variable metallic and non-metallic minerals are sparsely disseminated or scattered as fine grains throughout or just a part of the host rock. Massive deposits with more than 60% sulfides, usually volcanogenic massive sulfides or sediment-hosted, are formed due to the accumulations on or near the seafloor in association with volcanic activities or hydrothermal emanations, along with sedimentary deposition. Porphyry, which refers to an igneous rock that consists of large-grained crystals, such as those of quartz and feldspar, is scattered in a fine-grained ground mass. The ground mass is composed of indistinguishable crystals like aphanites, as in basalt, or easily distinguishable, such as phanerites, as in granite. Porphyry deposits are formed by the differentiation and cooling of a column of rising magma in stages. The differentiation stages of cooling create porphyritic textures in intrusive as well as in subvolcanic rocks. This process leads to a separation of dissolved metals into distinct zones and is responsible for the formation of rich deposits of copper, molybdenum, gold, tin, zinc, and lead in the intrusive rock itself. Hydrothermal, volcanogenic, and sediment-hosted mineralizations closely resemble sedimentary stratification. Stratification is formed by the upward-moving metal-bearing hydrothermal solutions through fissured rocks to deposit ore minerals in the overlying layers of pre-existing rocks. Ore minerals in strata-bound deposits are exclusively confined within a single specific stratigraphic unit, including layers, rhythmic stratiform, veinlets, stringers, and alteration zones, either conformable or unconformable with the bedding. Layered, rhythmic, and buried types of deposits are generally formed by the deposition and consolidation of sediments that may or may not be metamorphosed. The type of deposit formed this way depends on the composition of the source of the sediments. Examples of ore deposits that display such features are iron ore, lignite, and coal. Layered and rhythmic features are also developed during the differential crystallization of mafic and ultramafic magmas within huge magma chambers over prolonged periods of time. In the early crystallization stage, heavy metal-rich layers composed of chromium, nickel, copper, platinum, palladium, disseminated sulfides, minus plus gold and silver are formed, and in the late stage of the crystallization process, the solidification of the residual magma forms alternate layers of dunite, peridotite, gabbro, and anorthosite. Then the whole process is repeated with the addition of another quantity of fresh magma.